Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. How you guys and girls doing? It's been so long. It's been like 2-3 years. So I'm sorry about that. What am I gonna do? Got kids, all that stuff, but we're back somehow doing something. So I thought I'd start off with this simple game series because it's pretty easy to get back into. It will give me the chance to just catch up and do some stuff. And I know a lot of people like this series, so I'll probably keep working on this just as a start, and then we'll slowly ramp it up and get back to other stuff. One thing I noticed is it takes quite a long time to make these videos in the evenings like this, because that's the only time I have. I just have a few hours in the evening. So making a video a week is probably what I'm aiming at here. Hopefully that's good enough for now. But I'm not going to waste your time with all that chatter. I will bring it up in another video. But this video is going to be about the tile map for this side scroller simple game. So the tile map that we were creating in the last video was just a little skeleton, just a few things to get started. Then we have tiles as well, which will be the actual tiles, which the player can interact with. And the tile map will just contain those, and we'll be able to place those out. So my idea with the game was, maybe it wasn't really clear from before, is that the player will be jumping on these tiles while placing them. And then when you run out of tiles, you kind of had to find these tiles. You have to pick up these power-ups falling down, and then you'll get more tiles, which you can place, and you'll keep going up and up and up. So it'll be kind of just like an endless jumping side scroller. Something to work on. We'll bring up a lot of topics here, lots of array management, player management, collision, stuff like that. So it's still a simple game, but it's not too simple. To get started, I have a new structure, so we're going to go file by file. It's a little more planned out now. It's not as ad hoc as before. So what we're going to do, and ad hoc means basically just on the fly. So it's not as much on the fly. It's a little more planned out. So let's start off with the smallest component, I would say, would be the tile. And let's start in the H file, which seems appropriate. So first of all, in the H file, we have a texture here, which is passed by reference. This is also passed by reference, but it will be changed to a pointer to make our lives a little easier in the future, because there's some changes coming up that will affect this. So we'll just change that in the H file. That's it, pretty much for the H file. We'll jump to the CPP file and do the same thing. Just make it to a pointer instead. And that means that when we set the texture, if you look at the sprite set texture function, it takes a texture reference. And that's why we have to dereference this so that it comes back as the object itself being passed to the texture function here. So that's it for the tile class. So I'll just close that for now. Now we'll go on to the actual tile map. And what we have to do here in the H file is just a few things. We have to add quite a few functions and stuff like that. But let's get started from the top. Basically, we need two new variables, and we'll place them down here below the tiles array itself. And the two new things we need is, for a tile map, it's important to have a texture sheet or a tile sheet, so we can actually pick the tile texture, so we just don't have bland white boxes, colored boxes floating around. So to create that, let's make a SF texture tile sheet. And that will contain the texture image, like I said. And then we need a tile size, because we want to keep track of the size of each of the tiles for this tile sheet. You can have another tile sheet with different size tiles. It doesn't matter. But for this tile sheet, it will be unique. For each tile sheet, it will be unique. So unsigned. Let's go on to the next part, which is the tile map constructor. So what we have now is we just have a default constructor, and that's not good enough for us. We need a specific constructor that will allow us to create a tile map with a texture sheet, a width and a height, tile size, all that. So let's start off by creating a constructor, unsigned width. So we want to assign a width and a height. It's always good. And then we want the texture sheet, which won't be created here. It will be passed on from outside, because usually in a game, you don't want to keep big textures and stuff. Let's do it like that. Big textures and stuff in these simple objects and stuff. You just keep them in your game class, and then you'll kind of push them through to wherever they're needed using pointers and such. So let's do unsigned tile size. So we'll do that. And then we need to update our render function, because what we're doing now is we're not sending anything through here, which means this class won't know where to render to. And I don't want to save the render target in the class itself. So let's look at an example here. If we look at player, it has a render target being passed in here to the render function, which will allow it to be rendered from the game class. So if we look at the render player function here, when we're rendering the player, we're passing in the window. So pretty much I want to do the same thing for the tile map. So let's do that. Let's make a SF texture pointer, SF render target reference target. And we're not doing a pointer because we don't want to have to dereference and stuff. If you have a reference, it's easy to just pass it in. So we have that there. Let's keep going. And that will mean that we have to jump into the CPP file. And this will be the meat of the tile map here. I'm going to remove that comment. Let's just start off with the render function here. Let's see. So we just need to add the SF render target. You might notice I'm a little rusty. It's been a while. Target. So we'll just add that so it doesn't complain. But let's start from the top. So the first thing we want to do is in the default constructor, we don't want to remove it completely since we have a few things we want to initialize in the worst case. So what I'm going to do is tile sheet equals null, since it's a pointer and we will probably never use this constructor. But if we ever do, we at least want to initialize this to null so it doesn't completely crash. And then we want to do this tile size to 0. So if this is either null or this is 0, either something has gone wrong, whatever, we will know by it crashing. At least it will be initialized to something. And then we will look at the TileMap, the new constructor we created, or are going to create or flesh out. We need to add the same beautiful parameters to it. Just like that. Look at that. Look how nice that looks. Good. And we'll start off by initializing the two variables that we had here in the same way. Not null though. Sorry, I might have forgotten to create this as a pointer. So you just want to do that in the H file. Now this will work fine. Next thing will be here. We'll just assign tile sheet to this. But the local variable that we're passing through, the parameter. So do that. And then tile size will be tile size. Good. Initialized. Perfect. Now to the initialization of the actual array. So if we look at this array here a little more, it's a vector of vectors which contain tile pointers. And hopefully in the last video I showed you a little bit how we're going to think about this, but I'll show you here as well. So let's imagine a 2D array like this. And hopefully you have read about 2D arrays before. So let's do this. What do we have? We have 5 times 5. So imagine if this tile map was 5 times 5. 5 columns and 5 rows. How would we initialize this? Well, if we look at this, the first vector here will contain the columns and the second vector will contain the rows. And the rows, objects within those, column and row, will contain the tile. So if you look at it as boxes, this is the first vector here at 5. And then each of those positions in that vector contains another vector, which is the rows. And then that vector contains the actual tile. So the tiles will be within these boxes here. So that's how it's going to look kind of visually. So let me keep this just so you guys can visualize it while we're coding it. It's always good to be extra clear. And the best way to initialize something like this is using for loops. So let me create a for loop here. Int I equals 0. And then I just realized we need to do one more thing before this. We need to actually initialize the first row here, which will contain, like I said, all the first column, what do you call it? First row of columns. You'll see what I mean. So tiles, this tiles dot resize width. Now resize is a vector function which allocates and initializes each spot in that newly allocated memory with a default value of whatever it's supposed to contain. So you'll see resize and you'll see a reserve, but reserve doesn't actually change the size of the vector. It's a little different. I just recommend you to read about reserve and resize, the difference, but use resize in this case. So now we know that we have this first row. 5, if we give it 5, it will be 5 wide. And each of these now needs to be initialized with rows. And for that, we need a for loop. And what we want to iterate through is I is less than this tiles dot size, since the size of this one is the width. Let me do that, and I plus plus. Good. Now I have a nice for loop. What do we do? Well, very simple. This tiles dot, or we'll do that one, at the position I. Why do I keep inserting? There you go. At the position I, so 0 would be this position, is, or dot resize. See, reserve popped up, resize. And then we will give it height and another thing here, and it will be null pointer. Now the second parameter here is what it's supposed to be initialized to. So this is how many, and each of those positions will have this as a default value. And since we have pointers inside our last vector here, they'll all be null pointers. Now you might be wondering why are we just initializing everything as null pointer? Is because we can check that position if it's a null pointer, and then we won't react to it. That's the thing. We won't render it, we won't update it or anything, since there's no tile there. But in practice, it's reserved. It's a reserved spot for a tile. So it's really easy for us to create a new tile in each of these positions whenever we want to and remove it from those positions. And it'll be like a grid structure, really easy. And we don't have to iterate through everything. If we keep track of our mouse position where it is on the screen, we can just find it really easily where we're clicking, and we'll just remove that tile. So you'll see as we go along, it will be much more clear. So I'm going to remove this now. That's how it's going to look internally. This should initialize it properly. And always good to have a destructor. So we want to delete all of these tiles if there is anything in them. I'm just going to copy the for loop here. There's going to be a little special for loop here. We're going to do a double for loop since we have a 2D array like that. And just pay attention here to change this to k so that we have another value here iterating through, so we can access that. Now, not tiles.size, but tiles at the position of i.size. Hopefully you understand that by now. So it will be the column itself, all the rows on the first position and the second and third. So what we want to do is just a simple delete on that position. There you go, at position k. So that tile will be deleted. Nothing special. We can just do a raw delete here because we'll make sure that everything is null pointer. When you delete something that is a null pointer, it doesn't matter, it won't crash. And if there's something there, it will delete it. And what we need to do, just to ensure that everything is a null pointer, we have to initialize that as null pointer. And in this case, it's not very important since it's a destructor, but fine, we'll do that just in case. Now, that's pretty much done. Next thing we want to do is we want to be able to add a tile. So to add a tile, what do? Well, we want to make sure wherever we want to add a tile at this position that there's not a tile there, for example. So let's check for that, and that we're not outside of the range of the TileMap. Those two things are very important. So let's start off with the X here. If the X position is less than this tiles.size, then we'll do something. That'll make sure we're inside the width of the TileMap. Now we want to check for the Y as well. So if Y is less than this tiles at position X dot size, like that, then we will do, there you go. Oh, sorry, at position, yeah, well, it is at position X. Yes, good. So that Y, now we'll make sure that we're inside the TileMap, and we're not outside of the bounds, because that would crash the program, right? We don't have any position out there reserved for us to work on. So just like that. And then what will be done here is we want to check if it's a null pointer or not. Because if it is, we don't want to add a new tile there. We just want to add tiles to the places that are empty. So let's check that. Null pointer. So if it's not a null pointer, then we will add a tile. And to add a tile, all we have to do is this tiles at that position equals to a new tile, and then we have the constructor for tile, which should now take this tile sheet pointer. Since we have it as a pointer here, we can just pass it. That's why we changed it to the pointer in tile here, so we don't have to dereference it and stuff. It just works. So we'll pass that in, and then we'll pass in a int rect. So sf int rect, just what part of the texture we want. And for now, we'll just pass it a 0, 0, and then this tile size, So an int rect takes an X and a Y position, a top, the position of the top left corner, and then how wide and how high you want that rectangle to be. And it will just crop that out of whatever texture you're sending it. And in our case, it's nothing. It's always going to be the same thing. We haven't fixed this yet. Don't worry. We'll work on this in the next video. But for now, we just want to get it set up. So once you have this, that's pretty much the tile being created. And we can just double check that with this. So it takes an int rect, this, and a bool damaging as well. So I'm going to put that to false, just like that. And I think it has a default value already, but I just want to remember that it's there. So I will use that. Next thing we want to do now is to be able to remove a tile. Since it might be necessary sometimes, you could remove tiles to get tiles back to your counter, so you can add new tiles somewhere else. And just to remove tiles, it's going to be not as hard as this. We're not going to delete everything. We're just going to delete it at that position. So we basically, we want to probably take this instead. The same kind of thing. We don't want to click outside of the bounds. And we want to check if it's not a null pointer, then we will delete that tile. This tile. But what's more important here is that we have to initialize this, or set this to a null pointer after we have deleted it. Just so we keep that thing going, where we have a null pointer in all positions where, null pointer, where there is no tile. So we can freely delete it without being worried that it'll crash. So we'll put it all as null pointer. This looks good to me at the X and Y position. Looks great, really easy, nice to copy code like that. And once that's done, what we want to do is we want to fix the render. The update we'll leave for now. There's nothing special to update here, but the render is pretty important. So we have a new render target, and all we want to do is we want to iterate through all of our tiles and we want to render them out. So very simple, just like that. And we want to do a render for these. So this tiles, position I, position K dot render, it's a render like that. And then we want to pass in the target. So there we go. Perfect. It will render all the tiles for us. Really, really simple. And then we want to also do this if it's not a null pointer. So we have to make sure that we're not crashing it. If it's not null pointer, then we will render it. So that's exactly what we want to do. And we can actually, you know what we can do? We could just take this and we can add it to update just because, and we'll call the update function just like that, just because. And then whenever we work on update in tile, it will just work here for us. So we don't have to revisit this. Perfect. Now we have a few more changes to do. We have to make sure that this works in the game class, in our actual class. So let's do the same thing. Let's start with the H file. Let's go ahead and include TileMap because we haven't done that. TileMap.h. Perfect. Now we can use all that functionality. First things first, we want some kind of tile sheet to be able to use. And we don't have anything yet. So I'm just going to add a texture here. Sure. Tile sheet like that. And we'll initialize this eventually. And we also need a tile map. So we have a player. Let's add a tile map pointer tile map. Perfect. And to do all this, what we need is a tile. We need to actually load in a tile sheet, and then we need to create a tile map. So first of all, let's do an init void init tile sheet. Actually, it should be init textures, but fine. We'll keep it as tile sheet right now. And then we'll do a void init tile map. Good. Now we have two functions here that we can work with. Let's just go ahead and add everything we need before we go on to the CPP file. We're going to need a void update tile map and a render tile map. So void render tile map. Everything is divided into functions here. It feels a little better. Let me add one of these there, and we'll do that for the getter. Perfect. Now you can see it a little more clear. Functions up here. Let me remove that. Let me make it a little more clean. Good. So these are the four functions we're going to need. So I'm going to cheat a little bit. I'm going to do control dot, create a definition, control dot, create a definition. Good. Save that. Do it for, oops, sorry. Do it for that as well. And then the render tile map. Good. So we have a skeleton for everything. Now we'll jump into the CPP class or file, and we'll start working on that. So the first thing we did was the tile sheet. So let me find the init tile sheet here. And I was thinking we'll just use a texture that we have because I haven't uploaded a texture yet that we can use. So I'm going to steal it from player init texture. I'm just going to grab that. No harm in that, just to try it out. And then we'll call it tile sheet. Load from file, and we'll load the player sheet that we have. Now, once we change it, we can change it right here, and we'll load whatever we want. The only thing I want to change is this error message. This is in the game class here. Could not load the tile sheet. Good. So that's pretty much done. We shouldn't forget to call these later. So let's remember that. But let's start off with creating all of them. To init the tile map, we want to call our new constructor that we made. So it's tile map equals new tile map, and then that constructor. So let's say we want it, let's just start with, what do you want? 50 times 50. What is that? Let's do a 2020. Let's just start with 2020. And then we'll work on it because each of the tiles is going to be 50 pixels wide. So 20 sounds pretty good. 200 pixels. We'll see. We'll work on that. And then we want to just do this tile sheet. And since this is not a pointer, I'm going to, or it should be a pointer. There you go. It should be fine. It is a pointer. What am I saying, guys? I'm so rusty. God, this should be just fine here. Let me see. Let me do that. Okay, good. So the tile map wants the pointer. Yes, tile sheet, sorry. And the game has a tile sheet here, which is not a pointer. That's what I'm saying. It is not a pointer. That's why we need to send it as a address, the address to that object, to our pointer parameter here. Good. So that will be created for us. Now we need to do this. Tile map, add tile, just to try it out. This is what we want to do. If this works in the end, that means that we have succeeded for this video. But let's keep going. Now, update tile map. Update tile map right here. So this is very simple. We're just going to do this tile map update. That's it. That's pretty much it. Nothing harder than that. And then we're going to do the same for render tile map. This TileMap render. And what this is going to do is it's going to take our target here, which is, sorry, it's this window. No. Good. And that will allow us to render our tile map. And then we'll hopefully see our little white box, or our box of the texture of the player pop up. So good. Let's go ahead and call all the init functions that we created. So we have a little init here. And let's call this init tile sheet to load the texture, and this init tile map to load that. And what else do we need to do? We need to delete the tile map as well, because we created it. Tile map shouldn't be a problem. It should delete all the tiles as well within itself, since that constructor deletes the tiles, or destructor, sorry, deletes the tiles. It's like, guys, what do you want me to do? I'm doing my best here. Great. Now we want to call the update tile map function itself in the game.update, because we haven't done that right here. So I'm going to do it at the bottom. Update, sorry, tile map. Great. And then the render, which is also nice. So we're just going to render it above the player, and which is important. Otherwise, your player is going to be covered by the tile map. You want the player to be rendered after the tile map on top of it, or at least most of those elements. Now, what I usually do if I have foreground elements is I create two functions that renders them in different orders, or I create priorities. But that was way back. I haven't done that in a while. But we'll probably get to that sometime. Nice. So this should be good for us to render a tile map on the screen. Nice. It runs, but we don't see a tile. All right. Sorry, guys. I found the issue. I'm so dumb. Obviously, in the add tile function in the tilemap.cpp file, we want to make sure this is null pointer when we're adding the tile, not, because this is how it was. And that means that if there is a tile there already, then it will add a tile. And that doesn't make sense. So we just want to add a tile when there's nothing there. So when we do this and we run this again, we're going to see that we have a little tile here, whatever. All right, so I just noticed that we cannot move the sprite or the tile when we're creating it. And we're going to have to add functionality for that soon. But what this proves is that the tile map works. We're getting a tile on screen, although they're all printed at the same position. So that's why that issue is there. We'll work on it in the next video. We'll fix that, make sure we can add tiles where we want, and we'll have a nicer tile sheet to work with. Now, before we end this video, what we're going to do is we have a few more things to fix, just some quality of life things I noticed in the player class. So in the player, what we have to do is in the CPP file is the only thing we have to touch. There are a few values here that we want to change. Now make sure that in your game, you have a 60 frame rate frame limit. The thing is, we're not using delta time, so we're not all on the same clock. But if we all lock our frame rates to 60, we'll get the same results from our calculations. So make sure it's on 60. Hopefully your computer can run this on 60. It probably should, unless you are way back in the 80s, but this should be fine. So change your acceleration in the init physics function in the player CPP file, and change that acceleration to 3.0f, because I think it's a little too much. So I'm going to put that to 3.0. I'm going to change the drag to 8.0. Once we do that, we have a little nicer movement to work with. The next thing we want to do is we want to actually reset the velocity in the x direction. If the float value gets a little too small, I notice it's a little weird when it's really small. It's just gliding forward. So I'm just going to add a little thing for that. And to do that, we need to go to the update physics function. And before the move call, what we're going to do is we're going to add the functionality. So if, remove that, std, absolute. So the absolute velocity, no matter if it's negative or positive, if it's below something, we'll put it to 0. That's what we want to do. So this velocity.x is less than or equal to 1.f. We'll put it at 1.f. Then we'll just reset it. So this velocity.x equals 0.f. That's what we want to do. So we're just checking that it's less than this. Then we'll put it to 0. Then we won't get that weird behavior when the player is just about to stop. Great. Next thing is the animation. So I noticed that what we did for the animation was that we set it to moving left or right, depending on if a key is pressed. And what happens is as soon as you release the key, the animation stops, but the player keeps moving. So that feels a little weird. The thing we're about to do is also a little weird, but it's less weird, I feel. I'm also going to remove these comments so it looks a little cleaner. What we'll do is we'll put that to be decided by the velocity instead. So if this velocity.x is greater than 0.f, then we shall do the anim state to move. What will it be? Right, I think. So it will move right. And you make sure to remove it from wherever that is. And I'll control X this as well. And then you want to add an else if, not a if, but an else if this velocity.x is less than 0.f, then we're going to do a moving left. And then else, if it is nothing else, we'll put it to idle. So let me just add that there. Now we have to be really careful with this. And as we go on in the videos, you'll see that we'll change this up a little bit. But for now, once we don't have a jump animation, these are all the animations we have. It's fine. But once we get to another point, we'll change this up. But this is good. Now if we run our game, it hopefully will look a little smoother. And we have our little dude here. So it looks a little better. It's a little jerky at the end here because the animation speed depends on the player's speed. So that's why, but it looks a little better. It doesn't just stop when you let the key go. So hopefully you are happy with this. I'm kind of happy with this right now. For a simple game, it's pretty good. If we were making a more complicated game, I would probably not do it like this. But thank you guys and girls. Hopefully you like this video. Hopefully you like this return. It's a little rusty. We'll get better. I promise. I'm working on it. Good luck with the coding. Good luck with everything. Just let me know if there's any issues. I'll try to answer. I have a few hours in the evenings where I can look at comments and I can do stuff. So hopefully you enjoyed this. I'll see you in the next one, all right?